Okay, in the final question, we're asked to take a velocity versus time graph and plot it from an acceleration versus time graph for an object undergoing linear motion. We're told the initial velocity of the object is minus 4 meters per second, and that's shown on the graph. And so we have to draw our velocity versus time graph. So to start out with, in a problem like this, we say, well, acceleration and velocity are related through the change in velocity is equal to the area under an acceleration versus time curve. So for this segment, we can calculate the area under this acceleration versus time curve. It's just 3 times 1 second is 3 meters per second. We see that this is constant acceleration, which corresponds to a straight line between minus 4 meters per second and the new value at minus 4 plus 3 equals minus 1 meters per second. And we draw a straight line between those two. Then we have no acceleration for the next second, and so our velocity does not change. We have a negative acceleration for the next second. Our velocity changes by the area under that curve. It's a negative area in this case. Minus 1 times 1 is minus 1 meters per second. So our velocity becomes minus 1. Take away 1 is minus 2 meters per second. And again, this is constant acceleration. So this is a constant slope. So we draw a straight line. Our acceleration goes to 0, so we're at constant velocity for the next second. And then we have a changing acceleration with time. It changes linearly with time. Change in velocity for this time interval is the area under this triangle, which is a half base times the height. The height of this triangle is 2 meters per second squared. The base is 1, so that's 2 times a half is 1 meter per second that it changes by. So after this time interval, it'll be up here. If we cut this time interval in half, we see that we won't have nearly as much change in time interval by the halfway point. So this is a change in time of half a second. Change in velocity of a half goes up to 1 meter per second squared in half a second. And so this gives us a quarter meters per second as our change. So we go up by a quarter of the distance and over by a half. And we see that this is an upward facing parabola over that time interval. And then the final time interval is 1 second at 2 meters per second squared, which gives us a change in velocity of 2 meters per second. So 2 times 1 second. So that takes us up to there, and it should agree with the slope that our parabola extrapolated to, and we have a straight line again.